Hey everybody, in this video we are going to be working through the final exam review, and this video will be focused on Module 4, which was covering scientific notation. So in the review packet, there are 6 examples that cover um, from the material for Module 4. So we're going to work through these examples together here. So the first topic in Module 4 was dealing with when we multiply or divide anything that has exponents in it. And so in this first example right here, we've got a fraction and it's y to the power of 7 divided by y to the power of -3. So during module 4, we had talked about 2 rules. The first rule, or one of the rules, was whenever you have division, that tells us to subtract the exponents. And this can be done when your base, meaning whatever isn't the exponent, is the same. So since both of these have the same base y, we can apply this rule where since we see there's division, we're going to subtract the exponents. So to rewrite this, we would just rewrite it as y to the power of 7 minus -3. So since this exponent here already had a negative with it, we're still going to include that extra negative. So it's 7 minus and then -3. You subtract whatever the 2 exponents are, and then you simplify it from there. So simplifying 7 minus -3, that's the same thing as 7 plus 3. So this is going to turn into y to the power of 10. And an intermediate step you could have written there was y to the 7 plus 3 from there, and that's how we get that 10. So simplified here, this is y to the power of 10. Whenever we multiply, there was also a different rule as well. Since we subtracted exponents when there was division, if there's multiplication, then we're going to add the exponents instead of subtracting. So next to multiplication, I'll put that we need to add the exponents. And we can do this if we have exponents that all have the same base. So they all have 10 as the base here. These extra numbers here are part of the scientific notation format. And so whenever you have these additional multiplied values out here, you can separately multiply those numbers. So if you see a question like this, has a lot of pieces to it, we can take it one step at a time. The first step is to multiply those 3 values right there. So I'll just write uh, over here for step 1, multiply non-exponent values. So 3.23, 2.5, and 5.6. We would multiply those in our scientific calculator. 3.23 times 2.5 times 5.6. And that gives us 45.22. Then the next step would be to multiply the values that have exponents. So multiply exponent values, and I'll just put in parentheses add exponents. See, if we're multiplying all of these, that's the same thing as taking each exponent and adding them up. So right here, over off to the side, I'll kind of just write this out that we've got 10 to the power of 4 plus -7 plus -8. And I'm pulling those three numbers from the three exponents, 4, -7, -8. That's where I get those from. We add them all up because we've got multiplication going all the way across. So when we do this, we end up getting a 10 again, with the 10 stays, and when we add up these exponents, 4 plus -7 plus -8, since we're adding these negatives, it's kind of like subtracting. So it's sort of like adding or subtracting the exponents depending on if they're positive or negative. But in this case, we do 4 minus 7 minus 8, or 4 minus 15, whatever way you want to kind of approach that. You're combining all three of these though. And when you do that, you get a value, or you should get a value of -11. So you can do that in your calculator in different ways, but I would do like 4 minus 7 minus 8, 4 minus 7 minus 8, right? And there is your -11. That's where that came from. That's where that -11 came from. And I'm still going to put multiplication in between because we still have these multiplication symbols here. So this is scientific notation. However, when we talked about scientific notation, there's a specific way to write this answer. And right now it looks like it's scientific notation, but back in module 4, we had talked about scientific notation is where that first number is always between 0 and 10. In this current example, it's a number larger than 10. So to convert this to scientific notation, we need for this decimal to move over one space. Notice how I'm using the same digits 4522, but instead of 45, I have 4.5 now. I move that decimal one space to the left. And when we do that, it's going to change this exponent because this entire value needs to be equivalent to this one. So if we change 45.22 to 4.522, whenever we move our decimal to the left, that indicates that we should add 1 to the exponent in our next answer. Right here, add 1 to the exponent, meaning this exponent right here. I should actually write this over here. And this would then become -10. And so on your exam, most of your answers should be, or all of them should be, in scientific notation. So the correct one would be that one right there, because this number is between 1 and 10. Let's try another example. This one gives us a very large number, 3,529,000,000, and we need to rewrite it in scientific notation. So just like the notes before, in these four examples, whenever we have large numbers and we convert them, we're using the same digits from the original number, but we're kind of ignoring the zeros, and those extra zeros are what turn into that exponent. And so depending on how many decimals there are, that's going to determine what our 10 to the power of some exponent is going to be. So in this case, we see that currently it's a very large number, and in order to turn these digits into a number between 1 and 10, that's our rule of thumb, right? 3, 5, 2, 9, and then we ignore the rest of the zeros. We would want that to become 3.529. Needs to be between 1 and 10. So 3.529 is between 1 and 10. And then this would be times 10 to some power. We don't know that until we determine how much or how many spaces did we move this decimal. So we moved it 3, 6, 7, 8, 9 spaces. We moved it left 9 spaces. So what does that mean as far as this exponent now? And sometimes we move the decimal to the left, and sometimes we'll move it to the right, depending on the number. When we moved the decimal to the left, we did that because this was a very large number. There were a lot of zeros and then the decimal, so we had to move our decimal left. Whenever we have a large number, you'll notice that in those types of examples, your exponent is an added value or a positive. Whereas if you had a small number to start off with, your exponents are negative or subtracted. So whenever we move our decimal left, that's telling us to add to the current exponent. Left means add. So this would turn into 3.529 times 10 to the power of 9. Left 9 means add 9 right there. So there wasn't anything to start off, so we just put a positive 9 there. And there it is. There it is in scientific notation. On number 4 now, we have a similar example, except now we see that our decimal is at the beginning and we need to move it to the right to make this 3.27 times 10 to the, and then we don't know the exponent yet, but we need to count how many spaces did we move or how many digits did we move that decimal. So it started here. There's 3, 4, 5, 6 spaces that we moved it. We moved it to the right 6. And in examples where we had a small number to start off with, meaning a lot of zeros after the decimal, that turned our exponent into a negative or we subtracted. So this tells us whenever we have right 6 that we want to subtract from the exponent. So this would turn it into 3.27 times 10 to the negative 6. So looking at these two examples right here, you'll notice that large numbers have bigger exponents because 10 to the power of 9 becomes a large number, and that's what we want it to be equivalent to. Whereas a small number has negative exponents because negative exponents result in smaller values. So there you go. There's 3 and 4. Let's take a look at number 5. Number 5 says divide and then write your answer in scientific notation. So when we divide, we should just punch this into our calculator, but our answer is going to be a decimal, and we want that decimal to be in scientific notation. So the first step is to just divide it. We've got 16,000, and we're going to divide that, and we've got 25. What's that? 25 billion. We have 600 million, then 3 zeros, and then 3 more zeros. So that's 1, 2, 3, 1, 2, 3, 1, 2. Yep, that works. And depending on your calculator, you might get this answer right here, 6.25e negative 7. And that's actually helpful. Scientific calculators will do this. We get a really small decimal. It actually turned it into scientific notation for us. So let me write this and translate it for you. 6.25 e minus 7 is what we got from our calculator. That translates to 6.25 times 10 to the negative 7. But how do we get there, right? Like, let's say our scientific calculator gave us a long decimal. Well, this actually is equivalent to, so just going back like one intermediate step, this value as a decimal is written as 0 point, and then we got 0, 0, 0, 0, 0, 0, 625. Some calculators have a lot of spaces that it can use on the screen, and some don't. So it really depends on which calculator you're using. But this could have given us a decimal answer like this, and it may not have converted it for us. And so if it gave us this decimal right here, well, that was our first step, was to divide, and then we would write the scientific notation out. Well, to write scientific notation, we would need to move this decimal to the right 7 spaces, right? If you count, there's 6 zeros and then one more after that. So that's right 7. So when you move it to the right 7, we end up with these 3 digits, 6.25, which is right there. And then since we went right 7, there's where that -7 comes from. So all of this turns into that right there. So there's that intermediate step. Now, sometimes your calculator will just go straight from this when you type it in and tell you that right there. Well, that right there kind of converted it to scientific notation for you. The E stands for exponent -7. It's assumed that this is going to be a 10. Now on the exam, your answer should look like this right here. Let's do one last example. It says divide and then write your answer in scientific notation. So the first step is to address the non-exponent values and we divide them. So when we divide these, 2.6 divided by 1.04, we end up getting 2.5. So that gives us 2.5 times, I'm going to write 10 already because I know these two have 10, so I just need to uh, divide these, and when I divide them, we're going to subtract the exponents. So that's 10 to the, and this would end up being -4 minus -5. So you have to be careful if there's already negatives in there that you subtract or you put a minus sign in between the two numbers themselves. So -4 minus -5, that's like -4 plus 5, which is equal to just a regular 1 actually. So 10 to the power of 1. There's your answer. So these are just 6 sample problems of what kind of questions you could expect on on the final exam. But of course, there are more examples in your Module 4 notes, so feel free to go back and watch that lecture again if you need more practice with this. Take a look at your assignments from week 4 and go back over those examples as well to review. If you have more questions about this topic, feel free to email me or let me know, and I'm happy to help you out. In the next video, we're going to look at Module 5. So I'm going to pause the video here and we'll continue in the next video.